is using your technology? And then we're probably going to go 2 by 2 on questions, and I'll turn it back to Keith. So my 2 questions will be, who all is using the technology? And then maybe let's take a single example, like let's take Parkinson's disease and hear what you think might happen in the future. What's happening with it now, if anything, and hear how you think this technology might help us come up with some new solutions to an affliction like Parkinson's. So who's using it? And then that single example.
Sure. So our customers, for the most part, are academic researchers, scientists who are trying to make discoveries. These are research institutions, universities, genome centers, colleges. We are in, there's different surveys that get made of like what are the top researching institutions in the world. We're in all of them, like the top 100 institutions, for example. And it's one of those things where we have instruments that we sell to go into those institutions, and usually there's many labs in all of them. And so we tend to, over time, we've grown both in terms of the number of institutions that purchase our products, but also the number of labs within those institutions that purchase our products. So scientists is a big again, academia is a huge part of our business. Also a big and rapidly growing part of our business is pharmaceutical companies and biotechnology companies. So companies that are developing therapies and drugs and vaccines, right, to treat diseases. They tend to follow the academia, because academics almost by definition, they like to jump into new technologies because that allows them to kind of be on the cutting edge to make discoveries ahead of others. Pharmaceutical companies kind of see what happens in the academia world, and then they follow to and adopt new technologies. And we're seeing that happening now. So kind of by the same measure, if you look at top 20 global biopharmaceutical companies, for example, they're all customers of ours, and for the most part, large customers of ours. But you also see a very long tail of smaller biotechnology companies that are working on developing drugs for particular indications that are also customers. So that's kind of give you a broad spectrum. There's, I guess, one other kind of customer type is kind of more of a hospitals, or at least academic hospitals, where people are starting to think in terms of how this technology might apply in a clinical setting. This we see as a huge part of our future, but it is early days for now, although those customers exist as well.
And before you take that example of Parkinson's, with those customers, they're buying the equipment and then they're buying the consumable side. Maybe they're getting services as well in there. Can you just talk about the price point of the equipment and how that
right.
pricing and economics play out?
Right. So, we kind of, this business model is usually oftentimes called kind of razor blade model, although our razors are relatively expensive and razor blades are as well. So the instruments that we sell range in price roughly from $75,000 to $100,000. And we have one version that's over $200,000. So they're substantial pieces of equipment, although fairly modest on the scale of what researchers typically have to pay for capital equipment. And then our customers have to buy reagents and cartridges to run experiments on those instruments. And the range in price is roughly from $1,000 to maybe a few tens of $1,000s per experiment. So those are fairly substantial, again, expenditures, but relatively modest and relative to certainly the value that they get back from it. And so maybe on the question of Parkinson's as kind of an example. So this is a disease that's actually fairly, when we look at the range of diseases which ones we understand and which ones we're like kind of far along in understanding, which ones we're kind of early in understanding. Parkinson's, and I'd say neurodegeneration in general, is pretty early in terms of our kind of understanding of what causes those diseases and and then how we're going to treat them. But first you need to understand the causes. And it is, we have some idea that it is there's multiple subtypes of Parkinson's. It's not necessarily always the same thing. But I think the main imperative is to understand the fundamental biology and what really causes and what is happening in there. And what we've seen, and there's actually a lot of interest within neurodegeneration in general, using our tools. Lots of scientists are using them, where people would Scientists would either take, diseased brains of, patients who've passed away to analyze them and compare them to healthy tissues, or more commonly doing experiments in mice that have sort of Parkinson's-like symptoms, mice that are made to kind of have these kinds of diseases. And then what people look at is, well, you look at these brains and you kind of look what is happening inside the cells of those brains, what genes are turned on, what are turned off, where they are turned off and turned on. And what people are learning, and there's actually like lots and lots of research now, where you're connecting, we've known for the last 10 maybe or so years that there's some genes that are associated with Parkinson's, but we had no idea how they are, like what is the actual function. We know this thing is somehow correlated, but what is it actually doing to make the disease? It's been sort of a open question. And now they're actually, by virtue of knowing like this particular gene is expressed in this cell, when this particular thing happens, you can start actually deconvolving sort of what is the path that leads you from being healthy to actually having this disease, which now tells you, at least in principle, these are the cells you would need to target, and these are the molecules with those cells you need to target at this time point if you want to kind of prevent or reverse the course of disease. That's broadly speaking kind of the path to the cure from where we are now, and lots of laboratories around the world are kind of now peeling apart different elements of that puzzle, and it's tremendously exciting. Something that was like a black box is now we're like peering into it and seeing what's happening.